So this video we will see about first order and second order system, how the response of first and second order system we will see, right. So in general, any first order system whose transfer function is denoted by 1 divided by 1 plus s into t. So this is the standard of first order system. So the power of s is 1. So hence it is called first order. So the output Laplace C of s by input Laplace is the transfer function 1 over 1 plus s into t. Now here R is the input and C is the output. When the input is a step function, so this is step function R of t, U of t, step function. It is like something like a step whose Laplace transform is 1 by s. Laplace is 1 by s. So input step function Laplace is 1 by s. So C of s equal to R, multiply this side. So R of s replace 1 over s. So you take a t common, t outside. When we take t outside, we have s plus 1 by t. So that t brought into numerator 1 divided by t. When we use partial fraction of this term, so denominator having two terms, so that is a by s plus b by s plus 1 by t. Finding the values of a and b, we have the value 1 and minus 1. So substitute a and b here. Then you take inverse Laplace transform. 1 over s is inverse is again 1. Step function Laplace is 1 by s. 1 by s inverse is 1. It is 1. So this is like 1 by s plus a. 1 by s plus a whose inverse Laplace is exponential function e power minus et. So when it is here plus, meaning plus 1 over s plus whose inverse is e power minus. Here the plus coefficient, that becomes minus. So 1 by s plus a value is 1 by t, so e power minus 1 by t. So this minus is as it is. So this is in s domain. When we take inverse Laplace transform, that becomes the time domain. So this is the output, otherwise called a response. Otherwise called response. So this is a response graph. C of t is equal to this. When we substitute t is equal to 0, so e power 0 value is 1. So 1 minus 1 is 0. When t is equal to 0, the function value C of t value is 1. When t is equal to infinity, e power minus infinity value is 0. So that means that time the function value is 1. So at that time function, when time t is equal to infinity, the output response is 1. So it is gradually increasing like a exponential function. So the output of first order system equation is 1 minus e power minus t by t. So memorize this. Response of second order system. So R of s is the input. So this is input. And C of s is the output, otherwise called a response. R of s input, C of s is the output, otherwise called a response. So this is the output by input, that is called a standard transfer function of a second order system, omega n square s square plus 2 delta omega n s plus omega n square. So here the terms are omega n is called a undamped natural frequency. This is an undamped natural frequency. This delta is called the damping ratio. And the relation between these two, omega n and delta, is omega d, that is called damped frequency. So this is a second order system. We are having the terms like this. So here delta is a variable that is called a damping ratio. Based on this delta value, the systems are classified into 4 types. When delta is equal to 0, that system is undamped system. When delta ranging from 0 to 1, in between 0 to 1, it is called underdamped system. When delta is equal to 1, that is critically damped system. When delta value is higher than 1, that is called overdamped system. So based on this delta, the output is also varies. output also varies, it depends on this delta value. So that we will see now. Now here, when the delta value is 0, that system is called undamped system, whose response equation, output equation, C of t is equal to this one. So we should memorize this for doing the problems. We should memorize this, right? So this is output diagram C of t, whose response is continuously oscillating. The output never becomes 0. It is continuously oscillating till the time is infinity. So that is why it is called undamped. Undamped. Never it becomes 0. It is continuously oscillating. It is as a function of cosine, right? And the second one is undamped system. Sorry, this is called underdamped system. This is called underdamped system. Underdamped system. Underdamped system where delta value ranging from 0 to 1. 0 to 1. So this is the output equation of a underdamped system. So memorize this equation. We have number of problems based on this equation, and this is the corresponding output graph of a response of second order underdamped system. So the response, our output is becomes 0 at one time. Gradually it becomes output becomes 0. The oscillation becomes 0 at one time. So this is called underdamped system. Now the next one is critically damped system, where we have delta value is 1. So this is a formula for output response. This is the corresponding output graph having at the time t is equal to t is equal to infinity. It reaches a steady state value called 1. It reaches a steady state value called 1. So this is called a critically damped system. The last one is when delta value, damping ratio value is higher than 1. So this is the output equation. So this one rarely problem asked, very rarely. So just whenever we need, we will explain this overdamped system in detail. So here there is no output. Only memorize this one. We will see the problem whenever it is required. I will explain more. So next, among the 4 cases based on the delta value, the second case where delta value ranges from 0 to 1, that system is called underdamped system. So this is the corresponding output waveform, output graph of underdamped system and the equation. So based on this, we have numerous number of problems. So that we will see. Right. So this expanded version of underdamped system C of t. We have the time domain specifications as a peak overshoot. MP first one is peak overshoot, and the second one is rise time, and a peak time, and a settling time, and of course we have the delay time. For each and every specifications, we have the separate derivation. That derivation results alone I have shown here. For a time being, we memorize all the things which will be useful for doing the problems. Coming videos, we will do number of problems based on these results. So rise time is nothing but pi minus theta divided by omega d, pi divided by omega d. Settling time is for a 2% error, to 2% allowable error, we can write 4 divided by delta into omega n. For 5%, 3 divided by delta omega n. We can remember like this, that is a 2 is a even number, the corresponding even number is 4. 5 is a odd number, the corresponding odd number is 3. So we can memorize like this. So here all the terms, it is a function of delta and omega. So all the time domain specifications, it is a function of delta and omega n. So the question will be asked by giving either one of this value, and they were asking to find what is the corresponding time domain specifications. So that we will see in the problems. Thank you. So the first problem, consider the differential equation, this equation with the initial condition x of 0 is equal to 1. The response, what is response x of t for time greater than 0 is. So 4 choices were given. Differential equation is given. Indirectly they were asking to what is the solution of this differential equation. So this is a differential equation. Again you take Laplace transform, differentiation of any x, that is s into x of s minus initial condition, constant Laplace is constant divided by s, 0.2 x of s, x variable Laplace is x of s. So taking x of s common, and this x of 0 brought to this side, and substituting this x of 0 as 1, given value is x of 0 is 1, and rearranging the terms, we have x of s is equal to s plus 10 over s into s plus 2. Now we have to find what is x of t. The question is asking what is x of t. So we need to go take a inverse Laplace transform. Inverse Laplace transform, for that we need to take partial fraction. Partial fraction we need to take. So this denominator having two terms, so we will write the n divided by s, a divided by s plus b divided by s plus 0.2. When we take a, no need to solve, when we take inverse Laplace transform, this becomes a plus, this is b, 1 divided by s plus 0.2, 1 over s plus 0.2, inverse Laplace is e power minus 0.2. So here we have a plus, so the inverse is e power minus. See the choice where it is. So this is not the case. Here a is missing, here also a is missing, but here a and b is present. The exponential term is minus, so exponential term is minus, so this is the answer. But when you see here the exponential term is plus, so this may not be the answer. So this is the correct answer. No need to solve to find the values of a and b. That's all. Next question. A unity feedback system has an open loop transfer function g of s is equal to k divided by s into s plus 10. The gain k for a system for a damping ratio 0.25 is. So they were asking what is the k value for damping ratio 0.25. 0.25, what is the k value they were asking. So here this is a standard control system diagram where we have g is the open loop function and h is the feedback function. Here they were mentioned as unity feedback. So this h value is 1. They were mentioned as unity feedback. So g of s value is this. For this system, the reduced form is output by input. Output by input is equal to g divided by 1 plus gh. So using this formula, this is g divided by 1 plus g into h. So when we reduce this, by taking LCM and reduce this, we have the form like this. But if we have the standard form omega n square, standard form of a second order system, omega n square divided by s square, this formula. Compare both. So k is equal to omega n square. So k is equal to omega n square, that is the one equation. Now 10 is equal to 2 delta omega n. 10 is equal to 2 delta omega n. So omega n is equal to 10 over 2 into del. 2 into del is given as 0.25, it is given in the problem. So omega n value is 20. So substitute this omega n here. That time we have the k value. K value is 400. So the question is asked for k del is equal to 0.25. What is the k value? K value is 400. Next problem. Consider a system with the transfer function g of s is equal to s plus is this function. The damping ratio is 0.5. What is the value of k? As like a previous problem. But in this problem, they have mentioned the transfer function. But in the previous problem, they were mentioned as open loop transfer function. But in this problem, they mentioned as the transfer function. So no need to form the, once again, you form the we form the second order system. Already it is in second order, so just to compare with the standard form. Now you see the standard form denominator, we have s square plus 2 delta omega n s plus omega n square. So it is in standard form. So you compare with this form with the standard equation. So given the transfer function is this, the characteristic equation is nothing but the denominator of a transfer function. So the denominator of transfer function is equal to 0. That is the characteristic equation. So bring into divided by s. So we have the term like this. Now compare with the standard form. This is standard form. When we compare this, omega n square is equal to 6 over k. So omega n is equal to square root of 6 by k. Again, this 2 delta omega n is equal to 1 over k. 2 delta omega n is equal to 1 over k. Substitute omega n is equal to square root of 6 by k. This delta is given as 0.5. So substituting all the values and reducing, we have the answer k is equal to 1 divided by 6. K is equal to 1 divided by 6. This is the answer. The next problem. The output of a standard second order system for unit step input is given by this. This is the output equation. The transfer function. What is the transfer function of the system? So we know the second order system standard response equation is 1 minus e power delta omega. So this is the term we have where omega n, so omega d is a damped natural frequency having the formula this theta is the tan inverse of having the formula this. So this is a thing we know already. We compare this output equation given in the problem and the standard output equation that we know. When we compare both exponential term e power minus del omega n t, here exponential term is e power 1 into t. So e power minus del omega t is equal to e power 1 into t. So compare the exponential term. We have the first equation is this. Del into omega n is equal to 1. Again coming to the coefficient term, exponential term having the coefficient is 2 over root 3. So 2 over root 3. Here we have the exponential term coefficient is 1 divided by square root of 1 minus delta square. Square root of 1 minus delta square. So comparing the coefficient terms. So in cross multiply and when we simplify, we have the damping ratio is delta is equal to 1 by 2. So substitute this delta is equal to 1 by 2 here. 1 by 2. So we have omega n is equal to 2. The standard form of standard second order equation, that is omega n square divided by s square plus 2 delta omega n s plus omega n square. So substituting omega n value and delta value. So we have the transfer function 4 divided by, so after simplifying we have the answer 4 divided by s square plus 2s plus 4. This term when we simplify we have the answer like this. So the question asked is y of t is given. They were asking what is the response y of s, that is called transfer function. That is called transfer function they were asking. So this is a transfer function 4 divided by s square plus 2s plus 4. Next problem. A second order system has a transfer function is given by, if the system is initially at rest, is subjected to a unit step input at t is equal to 0, the second peak in the response will be what? The 4 choices are given. So here we know the response of second order system. This is the graph. This is the first peak. TP is called first peak time. Again the second peak occurs here. So this is the second peak. The question is asked what is the second peak time. So from this here to here, what is the time they were asking. So generally the peak time formula is n into pi over omega d when n is equal to 1, that is first peak. That time the formula is pi by omega t. Now n is equal to 2, that is the second peak. Substitute t, n is equal to 2, and omega d formula is the damped natural frequency, that is omega n into root of 1 minus delta square. So this is the formula we have. Now again coming to the problem, so the given question is g of s is, we are writing, compare with the standard equation. When we compare, numerator we have omega n square, that is equal to 25, therefore omega n is equal to 5 radian per second. 5 radian per second. Now compare s coefficient, 2 delta omega n is equal to 8. 2 delta omega n is equal to 8. So from that we calculate the damping ratio is 0.8. Substitute this omega n and delta damping ratio value here. Therefore dp is equal to second peak time. They were asking second peak time. So second peak time is equal to 2 times pi, omega n value is 5. Delta damping ratio is 0.8. So when we simplify this, we have the answer 2 pi by 3. So the choice is 2 pi by 3. So this is the answer.